Hi folks, welcome to part 2 of the video for your grade 10 climate change project. So where we left off is we had found a scatter plot for the data that we had on the land temperature around the world, and we had found a function to represent this data. In this case here we used a cubic function, or a polynomial of order 3, because the exponent on x is 3. Now we have a pretty complicated function here, so working with it might not be so easy. So I'd like to show you some alternatives to actually working with your calculator. All right, so let's take a look at a couple of questions that you might be interested in. So here I might want to know what is the expected land temperature in 2050. So if I'm trying to make some sort of point as to how bad things are going to get over the years, I might want a particular year to be aiming for. Okay, the other question that I might have is a target temperature. Say 10.5 degrees Celsius worldwide is some sort of critical temperature that we want to try to avoid reaching. I might want to ask, when will the temperature reach 10.5 degrees Celsius? So let's recall what my function gave us. Okay, we had x, which was the year. Okay, and then I had y, which was the temperature. And if you remember, it wasn't the actual temperature, but it was above or below the baseline temperature of 8.64. All right. So if I want to know the expected land temperature in 2050, what they've given me is a time value. So I'm going to take my equation and I'm going to input x equals 2050. Okay. Whereas in the second part, if I want to know when the temperature will reach 10.5 degrees, it means I'm going to have to input a y value. All right. Now, since the y value doesn't represent the actual temperature, but how far away it is from 8.64, I'm going to input y equals 10.5 minus 8.64, which is equal to, let's make sure we don't make a mistake here. So 10.5 minus 8.64. Okay, so 1.86. So these are the two things we have to solve. Oops, 1.86. Okay, so let's go back to our function here. Now, again, inputting x equals 2050, I could actually do this in my calculator pretty easily, except for these really long numbers. So I'm going to show you an alternative. Now, inputting y as 1.86, that's the problem. We don't have any way. There's no formula. We have like the quadratic formula to solve this equation. If it was a linear or quadratic, I could solve it. In this case here, I don't have the tools. So again, I'm going to show you a nice online tool to do this. Okay, so let's go to Chrome. And the first thing that you're going to look for is, for the first part, for inputting an x value, is you're going to input a function evaluator. Evaluator. Okay, so let's see what happens. So what I want you to do is I want you to look for this Wolfram Alpha widget. Okay, so this is the one that's best to use. So go here, and what you're going to do is you're going to enter your function, and then you enter the value you're looking for. So I'm going to go here, and instead of typing it out, I'm just going to press Control C to copy this. Okay, let's make this a little larger so that we can see it nicely. Okay, and I'm just going to now do Control V, and you see that it copied it straight into my entry line. But there's a couple of things we have to add, because you see here it doesn't give you the x squared. So what you're going to do is Control and Control 6. You're going to see this little hat that represents exponents. So you can just put that in for the exponent. So again, we need to make this x cubed. So here, this is your shift, not Control 6, but Shift 6. Get a little hat, and now we have our function given completely. So there's our function, and we want to evaluate this at x equals 2050. Okay, so this is much quicker and much less chance of having an error than if I were to put this in my calculator. Okay, and here if you go to the bottom and you see 2.49. All right, so let's go back here, and what we have is that when x is 2050, y is equal to 2.49. So how am I going to get my temperature? Remember, I have to use my 8.64. My temperature is going to be 8.64 plus 2.49. And so let's calculate what that is. So 8.64 plus 2.49 is equal to 11.13 degrees Celsius. So this is where we used our equation to determine the temperature that we expect to find based on our data in 2050. So that's one way we can use that curve of best fit. Now let's go the other way around. Let's go to given a y value. Now remember what we said is if I replace y by 1.86, I don't know how to solve that equation. So this is where we're going to go back to Google and you're going to put in an equation solver. Okay, all the great things that are available for free online now, and you pick equation solver. And again, there's a few, but I want you to look for the Wolfram Alpha one. So there's our equation solver, and same thing here. I'm going to Control V. I'm going to put my equation. As before, I have to go input those exponent signs. So x squared and x cubed, my shift 6 to get my hat. And now I'm going to replace my y value by 1.86. And just press equals, and this is going to do all the work for us. All right. Takes a couple of seconds, and I go down, and I see that my answer is 2036. Okay, so now I can go and answer my question that when will the temperature reach 10.5 degrees Celsius when x is equal to 2036. Okay, so say for example 10.5 is some critical temperature. This is when we expect to reach there. So you might use this as a way to convince people that we need to take certain actions to avoid reaching 10.5 degrees Celsius before 2036. Okay, so again, just to recap, once you have your equation in Excel, all right, you can use these online tools. So remember, there's the function evaluator to input an x value and quickly get the y value, or a function solver when you input a y value and you have to solve for x. Okay, that's it for this now.